Uh, so last week we had a recorded video on matrix completion. Is that matrix completion, have you, any of you have gone through? Look like not. Matrix completion. Okay. So matrix completion is a very important topic for exam. As you have not attended the lab, most of you, so it is a part of exam. So going forward, we have seen some initial overview of intro to big data in 2 weeks ago. So today we will go forward how the big data world handles like terabyte, petabytes of data, what a traditional system cannot do, and then go through this distributed computing, why the distributed computing is there even before the big data came, and then some on Hadoop architecture, Hadoop File Storage System, SDFS, some OG, some SDFS processing, Hadoop cluster, and Hadoop ecosystem. So today's my lecture will be less textbook. It will be more like I'm telling. There is a very less slides are there, more of taking the case study and examples and how a real life situation comes, and then why a different members of Hadoop ecosystem is helping handling different kind of needs of the big data requirement. I think with that way, in a brief, we can know more about this world rather than going a more textbook kind of lectures. So as you going, I have taken this little bit in my last lecture, like the Hadoop history it originated from Google, because Google has a need of processing large data back even in 2002, 2003. So, and that time, that is the era when Yahoo was most famous, and Yahoo and Google all were trying to work in this area, but Google came and their first work came like Google File System, which was again a distributed file system. And then the MapReduce came, that is also by Google. And taking the inspiration from the Google and MapReduce, what is MapReduce, we will know next lecture. So taking inspiration from Google and work on distributed file system and also the MapReduce architecture, the two-person, Doug Cutting and Michael Caffarella, they developed a Hadoop system. And they developed this Hadoop system, and they and this project was actually funded by Yahoo. So you can understand Yahoo. So there is a story like Yahoo wanted to buy Google back in 2002, 2003. When Yahoo wanted to buy Google. So when Google had less income compared to Yahoo, Yahoo was the biggest one at that time as per the technological company. It was becoming the fast growing. But Google was not being sold, and unfortunate situation is a case study also that after a few years, Yahoo was being sold. So in 2002, Google made an investment on buying a YouTube. And that also raises, and 2004, Google came with the Gmail, and many innovative activity came up from Google. Anyway, so Yahoo funded this Hadoop project, and then this Doug Cutting and Michael Caffarella, they, after developing this Hadoop system or ecosystem, they given it to Apache that we want to make it free. So once the project goes to Apache, it becomes free to use and it is become open source. So after developing, they given it to Apache, and then it became, so why Hadoop was needed, we will come to know. And in 2008, using the Hadoop, terabytes sorting benchmark competition was being done in the least amount of time. And that time, in 2008 itself, a company called Cloudera, they came up with a commercial solution of Hadoop. So means since it's open source, so anyone can use it. Means if you are using the open source like Android platform, so the rule of open source is that if you are using the open source code like Apache released code, then you have to make a version free available also. But when something is free, then it doesn't come with a support. And if a company is using something free and without a support, a commercial company will not like to go only for free thing. They want support because they want to get the support if something goes wrong. So in 2008, Cloudera was the first company which came with a commercial version of Hadoop. And then after that, the Abro Chukwa also became a member of Hadoop family. 2010, the HBase came. HBase is a database system of Hadoop where a query can be run. Hive is a platform on Hadoop by using which we can run SQL query. And Pig is also another platform. Pig is not much in use these days. And that added the more versatility and more usability of Hadoop system. And later on, Zookeeper came. And Zookeeper became integrated into Hadoop. So far, Hadoop has 3 versions. So until 2013, Hadoop 2 was there. 2015 or 2017, Hadoop 3 came, and which has overcome many drawbacks of previous Hadoop version. And it came with NoSQL DB like Cassandra and machine learning library called Mahout, and other have been added. So this is a brief history of Hadoop and how the Hadoop has grown. We can call it Hadoop is not a new thing because it is already 2015. It is already 15-16 years old. So it is not a very new system, but it is not also very old system. So traditionally we have been using the RDBMS, right? The transactional data, and as I mentioned in the previous classes that when the different type of data started coming and need of new kind of databases arises. So when RDBMS system is there, what it is there, it is in the form of table, and table can be of kilobyte up to terabyte. So if it is a form of table, if you want to search something, if it is a small table, it is quick to search or find something and do some editing and do some modification. But as the table size grows bigger, then it becomes very difficult to do the searching fast and also do other operation faster. So what the solution proposed that normalize the data, right? Like you normalize the data so that the duplication of data is removed and the different things are kept in a different table so that the data duplicacy is not there. And if we need to make correlated information from those tables, then join query can be called, and then we can extract the related information. And that could help in keeping the data size smaller. But that was also not helping. The size was becoming bigger. So what proposed that divide the data into logical cluster. So you can see the logical cluster has been people have tried to put into the logical cluster. So a big data, and at the academic level or at the student level, we are used to see small size data like kilobyte or few megabyte. Usually we don't encounter terabyte or petabyte of data in when we are studying. But in industry, the data can be bigger, and even storing that big data in one place becoming a challenge. So industry started doing a logically distributing the data, and later on when needed, it can be combined to run a join query and get the data out. So to avoid the duplicity, we normalize. When the increase of data increases, then logical clustering is done. And that was actually, we get lot of table, data in lot of table, and join query is needed to make it useful. But that was also becoming slower. Means we can do this join query, etc., on a SQL kind of data. And that is the need came where the extraction of the information from the data, transformation into a suitable format, and then loading into the place where it can be used for further processing, right? So as you can see, the logical partitioning is one of the solution proposed. And so now if normalizing is giving a problem, why the one solution, one can say that why not denormalize it? But if we do a denormalize, the data will be too big, and running a query can take minutes to hours or even days if it is so big a database. So with the existing solution, with increase in size of the data, the queries was becoming slow, and also it cannot process the unstructured data, and which was actually becoming the requirement of current modern business industry. So what to do? The NoSQL kind of data came up. There are varieties of NoSQL database, and varieties of NoSQL database we will know in the next class. What are the different types of NoSQL database? So to handle the different kind of needs of the industry, a different kind of NoSQL database came up. One of the example NoSQL database is key value pair. Like if you see Amazon, right? Amazon for a product called Apple, right? Apple 10, if let's say Apple 11 phone. Apple 11 phone in Amazon, you can get lots of information, lots of sellers are there, and there are a lot of other accessories related to Amazon are there, or there are too many data is there. If they have to do a join query, and if let's say the data is there in a SQL format, table format, and if they have to run a join query, the way you get response now on Amazon, it would have not been possible. So there they are storing this data as a key value pair in a NoSQL format, and once you know the key and all the value related to the key will be immediately zoomed, and you see all the data there. So going back to our previous thing, right? Polyglot persistence. Polyglot persistence means the different varieties of data existing in the same time, and those are persistent data. They are not going away. They are going to be there. And among them, we have this CRM data, customer relationship management data in a table format in MySQL. There are transactional data in RDBMS format in Oracle. There are now companies are there which keep on buying companies, and they also have a third party which also give important data to them, and the data format they use it is XML. And then there is a social media data they are having. Every, let's say a bank, a Spara bank, they have a social media platform where they are getting the important interaction of their customer who is coming to their social media platform, liking, commenting, or asking question, or many other things are going on. So that coming in JSON format. And there are customer care calls are there. Customer care calls are coming that are being kept in a log file. And apart from that, there are many other type of data formats are there. And among this, only CRM and this MySQL and Oracle are structured data. Remaining all are unstructured data. Now, why then comes like, okay, we can keep those data, XML, JSON, flat file. I mean, storing the data is not a problem. We can really store the data. Like in the past also, CLOB, blob kind of databases came where we can keep both SQL and unstructured data, structured and unstructured data. But then though they were not allowing to processing. But if we do not do processing, what is the point in keeping XML, JSON, all this data if company cannot make anything reasonably out of it? So there comes a requirement called ETL, extract, transform, load. Like for a SQL kind of data, not much extraction is needed. But for data coming in XML format or a JSON format, so they are like a text file or in a XML format. Now, if we simply push it in a data warehouse, so but those data will not be of any use if it is not in a format where a processing is possible. So there are ETL tools are there back in 90s and early 2010 time early. The ETL tool were quite famous. There are many companies which came up whose job is to produce ETL software. And those ETL software comes with a different feature, like if you want to extract the data from XML. So basically, what ETL tool will do, it will extract the data from XML and transform it into a structured format, and then it will load it to the data warehouse. And in that way, they can be processed, right? Now, social media data also, they have to extract, and then they have to transform, and they have to load. Now that went to data warehouse. Now, these ETL systems are basically a single machine system. So they did not have a capacity to process the data, first of all, fast. And after that also, this ETL data was being kept into data warehouse. And this data warehouse, a primary use was the company's higher administration people. They want to immediately know certain thing from their data by which they can make a decision. Let's say Spara Bank CEO. Now, Spara Bank CEO, he has to make certain decision, day-to-day activity. He is not going to write an SQL query. Okay, it is not expected that a person of that level to know the SQL or even work with the system to write an SQL query and okay, how much sale was there, how much debt is there, how much the loan is getting defaulted. All these things the CEO is not going to do, and it is the amount of salary he is getting that is not justified with the time he is going to put to get the data. So his time is more valuable. There are companies, for example, let's say Oracle, the Oracle CEO Larry Ellison. His salary used to be 110, 120 million US dollar a year. So if he's putting a 5-minute time to run an SQL query, he may do it, or even Sundar Pichai is a good engineer and a programmer. He can write an SQL query. That is not a thing. But if he put his time on SQL query or doing a low-end job, then it is not justified with the amount of salaries he's getting and the productive outcome out of it. So then this data warehouse came, and where the ETL tool extract the data from different platform of which are structured and unstructured data type, and they are fed into the data warehouse. And on data warehouse, there are business intelligence tools are running. And for example, BI tool Tableau nowadays famous, so which can give a visualization and more analytics, which can help the company's administration to make decision or forecast or predict. Let's say they want to know that how much cash credit or credit is there. So company has to forecast 3 months, 6 months, a year. And based on that, they have to decide whether they want to raise money from the bank as a debt, or they want to go in a different market to get the money. So, and there are many other decisions the higher administrative people have to take. So my one friend is was working in ICICI Bank as in a senior post. ICICI Bank is the second biggest bank in India, and there they were using this data warehouse tool. Annually, they were paying $5 million just to use the data warehouse software. Apart from that, they have to put people, first of all, to do this ETL job, and then also to maintain the data warehouse and fix all the trouble coming up in the data warehouse. So, but money put was definitely valuable to the company. That's why they were putting 5 million. But still, using this so much expense, it was not a real time. The ETL tool will run overnight and then transform the data, or even maybe more. Nowadays, the data is more, and that will going to put into DW, and DW data warehouse can run on multiple cluster. It is not a single system thing, but still it was taking time, and that's why the need of more larger distributed file system evaluation arises. And there comes this Hadoop. So Hadoop is basically meant for not for a small transaction processing. It is meant for really handling a large data sets, large databases, or large data, both in structured and unstructured format. And it is primarily meant for batch processing. So it utilizes the multiple clusters to do this processing the large data. And there are also this high availability, disaster recovery, all those features are there. So Hadoop came in 2005 as an open source, and then Cloudera commercialized it. And in 2008, and later on, there is another company called Hortonworks came that also provide the Hadoop solution. They also have a free version, but they also provide a commercial solution. Cloudera also had a free version. They also provide a commercial solution. Then people who left Cloudera and Hortonworks, they together formed a company called Mapr. So Mapr is actually an Indian company based in Bangalore. And this was also providing a good, making some name in this Hadoop world. As of now, the stories comes down to that Cloudera actually bought Hortonworks. Now Hortonworks is no more Hortonworks. It is actually now Cloudera. And Mapr has been bought by Hewlett Packard, I think in 2019 or 20. So now Mapr belongs to Hewlett Packard. So at the moment, the Cloudera is there for providing Hadoop, and then Mapr belongs to Hewlett Packard. You have used Azure. The Microsoft has its own Hadoop platform, which called SD Insight, and it also gives Hadoop-based SQL platform. Like Azure SQL is actually Hadoop-based SQL platform, and Oracle also have its own platform. IBM has its own Hadoop platform. So there are many companies are there, but they work in their company. But in the open market, the Cloudera is the one which is currently the market leader in Hadoop. Slowly, a different requirement is coming up. and the different things becoming more important now instead of Hadoop. We will know later. Like Big Insight is there for IBM. SD Insight is there for Microsoft. So all these earlier system were actually working on single system. Then a solution came, network attached storage, NAS, EMC Square. Okay, yeah, there was a company called EMC Square. They came up with a solution which only job is to give NAS. And I remember I was working in when I was working in IBM in 2004. It is a very big building. Like if you anytime get a chance to go Bangalore in India, you can see how the Silicon Valley, the infrastructure look like. I'm not talking about how the city look like. I'm talking about how the infrastructure in the big companies there look like. So from IBM, means I was working, and then suddenly one day I saw the opposite building had a name called EMC Square. And I asked my friend, what is this EMC Square do? They said that they make software for a distributed platform. So now they were making this network attached storage platform. But this network attached storage also was not helping the world. And in that case, the SAN system came up, storage area network. And in storage area network, we can put lots of storage devices, and which are connected with via the storage area network protocol. And the need of actually storing the data can be solved. Like we can create 20,000 hard disk cluster, and that can solve a petabytes of, or even more than petabyte of data requirement. And that can be handled using SAN. Now, that was only storing the data. Just by storing the data is not going to help company, you know. Now, company wants to process the data. Now, just storing is not the requirement. And the SAN and NAS all were providing the solution which can scale up to a medium scale enterprise. But as you go scalable company, right, which actually growing in the past, or a big company like IBM, Microsoft, then it was not providing. By the way, this is for just trivia for information. The biggest Hadoop cluster was how many machine was there in the biggest Hadoop cluster. It was actually owned by Yahoo. And now Yahoo is not, it has been sold. It is not doing good. So the biggest cluster of Hadoop was there with Yahoo. It had 20,000 machine. 20,000 server was there in one Hadoop cluster. And that was been sold to some unknown company, which was not a big name. But now the biggest Hadoop cluster owned by Facebook, which has around 2,000 machines, not more than that. And that can store a petabyte of data, few petabytes of data it can store and handle. So as I said, NAS and SAN were not been able to support by 2004 and 5. Requirement was growing and growing. And when I was working in companies that time, it is ETL, extract, transform, load, or data warehousing, SAP, ABAP, SAP, ABAP, all those were very much in hype, the way you see a hype of cloud computing or machine learning. In 2000 to 2010, this ETL, SAP, ABAP, and Oracle DB or RDBMS DB was much in demand. High salary used to be given to people who know it. Slowly, as the time goes, the society changes, the technology changes, and the requirement changes. Now, if you search SAP job or ABAP job or data warehouse job. Very few jobs you will see. Now more and more the company requirement has shifted, so the job title and job requirement has shifted. So with the time, one has to be prepared with a change in the situation and scenario. So here we take a break of until